Hello YouTube, this is Umils03. In the previous lesson, we brought up something called JSON, and we said that JSON is a module where basically we have a dictionary wrapped inside of a string. And there are basically two functions, a loads function, which allows us to convert that string into an actual dictionary that we can use in Python and get values out of and find the length of and whatnot. But then it also has a dumps function, which goes the opposite direction. So that would allow us to feed in a dictionary or an int or a string and convert it to a JSON string. So what we're going to do is some review of JSON in this video, but I also wanted to talk about frozen dictionaries. And it turns out that like with stacks and queues, we actually have to build a class for a frozen dictionary, because as of this video, it's not something that's provided in Python like a frozen set was. So we're actually going to build a class for a frozen dictionary. We can think about a set of key value pairs that's immutable. But anyway, we know that exec of x executes string x, which must contain executable Python code, and then it would just execute that code. And then y equals iter of x creates an iterable on a data structure x, and we can call next of y for the next element. And then eval of x returns the literal value of the expression or variable within the string x. So if you say eval of and then w in quotes, then it would look for a variable called w and return the value of it. And then the sum of two matrices sums each entry in each corresponding row and column, and it can be implemented using a static method. We saw that in a recent video. You can find the minimum entry, maximum entry, or corner element in a matrix. You can find the number of entries, which would be the number of rows times the number of columns. A transpose of a matrix just flips the rows and columns, and that can be implemented using a static method. And then in this video, we can review JSON, which is a module for converting a string into a dictionary and vice versa. So it supplies loads and dumps. So exec of and then some string. And we have this in the context of if underscore underscore name underscore underscore equals equals double quotes underscore underscore main underscore underscore double quotes colon. So then that allows you to run your module as a script. So exec of and then this string, and we have E, F, G, H. So it's tuple unpacking equals tuple of, and then we concatenate two lists together. So the list 4-2 concatenated with a list that holds two strings, sup and not much. And we needed an escape sequence because it's in the context of a string, right? We're feeding this into the exec function. And so we could say print E, and then that would basically give us the 4. And then we could say print eval of F in double quotes, and that would give us the 2. And then we could say exec of print of G, and that would give us sup, and then exec of print of eval of H, and that would give us not much. So hopefully that's clear to you. And then we can say U equals frozen set of, and then pass in a regular set. And then we could say for K and U, print of K, and that would give us each of the 3 unique elements in the set, because incredible cannot come in twice, right? There are no duplicate elements allowed in a set. So that would just print incredible, influential, and inspiring. And then we can say for K an iter of U, print K. And then we could say print F, we could do an F string, like a formatted string, frozen set, and then in curly braces, we could just have U. So that would be, so then that would give us the frozen set again. But essentially we're just going to, within the context of the for loop, we're going to print each of the elements in the iterable after we printed each of the elements in the set. But the effects would be the same, right? And then we could say for K and list of iter of U, and then print K. So basically, iter of X or iter of U can be treated as a generator. Okay, and so that hopefully that makes sense to you how that works, and we can review that in the next few videos as well. And then we can say number of elements equals 0, V equals iter of U. While true, try S equals next to V. So we could try to call next to V as many times as we can, as many times as there are unique elements in that set U. And then try S equals next to V. And then except if there's a stop iteration issue with that, we could say print cannot get the next element, but it would have the effect of basically being able to say cannot get the next element and then breaking out of that loop. But there would be no runtime error because we caught the stop iteration using an exception. And then we could say print so the length is, and then it'd say so the length is 3. That would just give us the number of elements. But each time, if there's no stop iteration, we're going to increment the number of elements by 1. So this code from lines 218 to line 228 is one interesting way of determining the number of unique elements in the set. So hopefully you can understand how we can use a try, except, else block within the context of a while loop. And then we talked about matrices, right? So M1 equals, and then a list of lists, right? And then same thing for M2. And then we could say print R for R in arrays.sum matrix of M1 and M2. And we talked about this sum matrix static method we've talked about right here, right? We implemented this earlier and we talked about this. And then we already talked about the code for this, but it has the effect of summing, or in this case, concatenating the entries at each of the corresponding index positions. So hopefully that's clear to you. And then that's why we would get AB, UY, EV, SX, right? It's just concatenating each of the corresponding strings together. And then we could say try print arrays.difference matrix of M1 and M2, and we would get a type error with that, and it would say cannot subtract two strings within the context of the exec function. And then we could say print minimum of M1, that would give us A. Basically, that's the lowest, that would be the first element alphabetically, right? And then the last element alphabetically of M2 would be Y. So hopefully that's clear to you. And then we could print that essentially the top right of M2, that would be portrayed as X. Okay, and then the transpose of M1, we would go ahead and flip the rows and columns. So instead of A, U, E, S, P, R, T, Z, we would get A, P, U, R, E, T, S, Z. And then that's what we see here. So hopefully that's clear to you. And then we can talk about the JSON, right? So if we import, remember in the previous video, we were talking about how we can import a module under a different name. So we could say import JSON as J. So now if JSON has a function called dumps, we call j.dumps of s, right? Assuming it accepts one input. Okay, and here I'm just arbitrarily referring to that input as s. But hopefully that makes sense to you. And so now we're going to scroll down. And we went ahead and created our own function called JSON object. So JSON object of S, and it just returns j.loads of S. So we said that the JSON module provides a loads function, which accepts a string with a dictionary inside of it and just returns that dictionary. And that's what this partial doc string tells you. But in order to complete this doc string, you'd have to have a param section that describes what S is, right? And then JSON string, so this is a lambda function and it works the opposite way. So it says lambda W, j.dumps of W, because we said that the dumps function accepts basically an object and returns. So in general, it accepts a dictionary and returns the JSON string representation of it. So if we say my dictionary and then there's this string, right? This, I think this was from the previous video or a similar example, but it assigns the string A to 95. It assigns the string B to 85. And it assigns the string my number to 85 as well, because we said the values in a dictionary do not have to be unique. So it says my dictionary equals JSON object of my dictionary, print length of dictionary, and then length of my dictionary. So that would be 3, right? And then we could say my dictionary dot update of C with 75, right? Because now it's an actual Python dictionary that we can call the update method of, as we talked about in a previous video. And then if we try to print the dictionary, now the key value pair C75 has been added on. And then we can say my dictionary of D equals 65. This is another way to add a key value pair onto a dictionary. And then if we print it, you can see the dictionary is getting longer. And then we could say my dictionary dot pop of my number. And then we could say for Q in my dictionary, if my dictionary dot get of Q equals 85, print Q. So basically, if the value corresponding to that particular key value pair is 85, then I want to print the key that gives a value of 85. But now there's only one key that gives a value of 85 after we pop out the my number key, right? Then it's only B. So that's why we only print B after this loop. And then we can say S1, S2 equals 82, 84, so just two numbers. And then S3 equals 100 times S2 minus S1, so it'll just be 200. And then S3 equals JSON string of S3, so that will give us the string 200. So print length of S3 plus S3. Well, that would be the length of 200200, because that would be a concatenation of two strings, and that would be 6, right? And then if we go ahead and say print length of my dictionary equal length of JSON string of my dictionary, it would say false, right? Because the dictionary doesn't have the same length as the string that wraps the dictionary. And then if we say A equals 323, so that's a tuple, print type of A, and it gives us tuple, and then print type of JSON string of A, it says string. And then exec of Z equals, this is a very, very long value and a very, very short dictionary. So we can say short dictionary and then just one key value pair. So it assigns the int 2 to the value Z, which is this long string, and then print length of short dictionary colon equals JSON string of short dictionary. So using the walrus operator, what would be the length of the string, right? The JSON string, and that would be 73, not 1. So hopefully that's clear to you. What we're going to do in this video is talk about a frozen dictionary. So this is something that we can basically build a class for. So on line 4, we have class frozen dict. And basically, we're going to be able to implement a frozen dictionary, right? We've already talked about how a tuple is a version of a list that's immutable. We've already talked about how a frozen set is a version of a set that's immutable. Now we're going to build a frozen dict, which is a version of a dictionary that's immutable, right? You can create key value pairs and you can access them, but you can't change the values associated with existing keys, and you can't add new key value pairs. You can't remove key value pairs. It's just a set in stone dictionary. So we're going to say call native equals true, and we're going to have a constructor defined in it, and it's going to accept one dictionary. It's just going to accept a dictionary. So we'll call it my dictionary. And then we're going to say self.dictionary equals my dictionary. Okay. And then frozen dict.call native equals true. So you can ignore that class variable, but pay attention to lines 10 and 11, right? But you can say, or line 11. So self.dictionary equals my dictionary. So just like we based a stack and a queue on a list, we're going to base a frozen dictionary on a dictionary. And then now we have a length magic method. So how do we get the length of a frozen dictionary? Well, that would just be the length of the dictionary on which the frozen dictionary is based. And then how do we get an item out of the dictionary? So if we had square brackets after an instance of the frozen dictionary class, would that enable us to get a value? If we pass in a key, how do we get a value out? So we could say if it's not the case that the item that I pass into those square brackets is in self.dictionary.keys, return not in the dictionary. Otherwise, return self.dictionary of item. So if the key that we pass in actually exists in the dictionary on which the frozen dictionary instance is based, then we can return the value. But otherwise, we'll just say not in the dictionary. And then, but then we're not allowed to set items in the frozen dictionary because we're saying it's immutable. So we would just raise a type error, right? So hopefully that's clear to you. And then we can also say get. So we said there's two ways to get a value out of a regular dictionary, right? You can either say dictionary.get of item, or you can just say dictionary of item, right? And then if you call get, you use parentheses. And then if you don't call get, you use square brackets. But now we can have a get method, and it works very similarly to the get item magic method that we just talked about, but get of item. And so it'd be say, if it's not the case, the item is in self.dictionary.keys, return not in the dictionary, otherwise return self.dictionary of item. So it works the exact same way. And then we could have a string representation of a frozen dictionary, and we could just return the dictionary on which the frozen dictionary is based. And then we could see if an element is in the frozen dictionary, and we would say return eval of item in self.dictionary.keys. So if we pass in a particular element to see if it's in the frozen dictionary, we'll return true if and only if that element was one of the keys in the dictionary on which the frozen dictionary is based. And then maybe we could add two frozen dictionaries together. So that's the add magic method. So we could say new frozen dict equals dict, right? Where it's just going to be a regular dictionary to start. But we could say for k and self.dictionary.keys, new frozen dict of k equals self.dictionary.get of k. For v and other.dictionary.keys, so basically it seems like we're going to be appending items onto a list as long as there are no duplicate keys, right? Because it says for v and other.dictionary.keys, if it's not the case that v is in self.dictionary.keys, new dictionary of v equals other.dictionary.get of v. So basically it's adding elements into this dictionary as long as there are no, as long as the elements in the other dictionary or not, as long as the keys in the other dictionary don't overlap with the keys in the existing dictionary, right? But then we'll say q equals frozen dict of new frozen dict. So we're calling our constructor as we talked about previously, and then we could say return q. And then we could see contains value of some value, and then return value in self.dictionary.values, right? Because we said our contains magic method is going to see if it's in the key set, but then we could also see if it's in the values by calling the contains value instance method. That's something that we have the freedom to create. And then we also talked about a static and a class method. So these are examples of what we call factory methods. And you see decorators on top of them, but basically they have the effect of creating instances of our frozen dictionary class. So if we call the static method frozen dictionary function, it prints calling a static method to produce a frozen dictionary. And then it says return frozen dict of my dictionary. And then if we call the class method, it says print calling a class method to produce a frozen dictionary, right? And then we have to have something in the parentheses that indicates to Python that it's a class method, right? We have that with the class method, but not with the static method. But in both cases, we would return frozen dict of my dictionary, whatever, based on whatever dictionary parameter is passed in. So now let's go ahead and try this out. So what we're gonna do is I created a method called try frozen dictionary. So it says dictionary T equals, and then we have key value pairs here. So we say 1 and we assign it to bool of 1, and we know that bool of 1 is true. And then we assign 0 to bool of 0. Bool of 0 is false. And then it assigns the string potato to 5.75. It assigns the key 5.75 to tennis, and it assigns the key soccer to tennis, because we said the keys in a dictionary have to be unique, but not the value. So 2 unique keys are assigned to the same value. So print length of my dictionary T. So where is that? So I guess that would be this 5 here. That would be the 5, okay? And then we could say print dictionary T of length of dictionary T greater than 0. So what would that print? So basically, where are we here? So that would be the 5 here, length of dictionary T, and then print dictionary T of length of dictionary T greater than 0. Well, this is a true Boolean. And so basically what would this be mapped to? So this would go ahead and be mapped to true, okay? Because this would essentially be if you said dictionary T of 1. But the point is that the Boolean would be implicitly cast to an int, and it would have the same effect. So that's why you would get that 5 there, and then dictionary T of 1 would be true, right? What if you said dictionary T of potato? Well, then you would get 5.75, right? But those are just the workings of a regular dictionary. And then we can say print length of frozen dictionary T, and again, we get 5. And then we could say print frozen dictionary T of float of 5.75, and that would give us tennis, right? And then what we could do is we could say print frozen dictionary T of float of 5.75. So yeah, that would give us tennis. And then what about frozen dictionary T.get of soccer? Okay, so basically this would be an example of list slicing, as we talked about previously, but it would just call all the elements from the list. And here our list is essentially a list of characters. It's a string, but it says frozen dictionary T.get of soccer. So it'll give us the value associated with the key soccer. But the point, what you have to remember is that we built our frozen dictionary class based on a dictionary, and we already built in the functionality that allows us to use square brackets and to call the get method and to see the length of a frozen dictionary. But that's why magic methods are so critical, is now our frozen dictionary basically works almost as well as a regular dictionary, with the exception of we're not allowed to change the values associated with keys, and we're not allowed to add or remove key value pairs, right? But we're allowed to implement what would be thought of as a frozen dictionary. It's just an immutable collection of key value pairs. And so now we can keep testing the functionality. So if we say if we say print frozen dictionary T.get of soccer, that would give us tennis, because tennis is the value associated with that key in the frozen dictionary. And then what if we say print potato in frozen dictionary T? Well, that would give us true, because we said our contains magic method will return true if the potato is a key in the frozen dictionary. And here it is, right? Because we said frozen dictionary T equals frozen dict of dictionary T. And that's a key, right? But if we say print of tennis lower in frozen dictionary T, well, tennis is a value, but it's not a key. So that's why that would return false. And then we can test our add magic method, right? So if we say frozen dictionary U equals frozen dict of potato with 999, summer with June, July, August, and then we say frozen dictionary V equals frozen dictionary T plus frozen dictionary U. So adding adding together these two frozen dictionaries, and then we could say print frozen dictionary of V, and then we would get all of these elements, and you could see that the value associated with the key potato has not been replaced with 999 because we specified in our add magic method that we were only going to add a new key value pair into this sum frozen dictionary if the keys didn't overlap, but here the keys don't overlap. So we retain the original value, but that's testing out our add magic method. And then we can test out our class method frozen dictionary function and our static method frozen dictionary function. You can keep trying this out, but basically the point is that a frozen dictionary could be implemented with a class, and we can see other examples in the next video. We're going to talk about the callable function, which is a standard function in Python, but there's going to be 3 more Python videos, and hopefully you're getting the sense of how you can implement basically anything you want as long as you use the appropriate magic method. So hopefully that was interesting from you, Moso3. Thanks for watching, and please subscribe.